Welcome to Homework Lib.
Hi everybody. So this is asking a graph the values in the table as E versus, so it wants it as E versus ln of 1 f E minus 1. Okay. And find the slope of the y and use results to calculate. Okay, so for this, so it gives us the Fermi-Dirac distribution probability of a given state, and so we need that. And let me write this. Okay, kt plus 1. Okay, and so for this is what we're going to be using to find the data. Okay, this is the equation that we'll be using to find the table. Okay, and this is how I filled in the table for you guys. And we'll draw a graph as well for the slope. And the graph is basically using this, the figures for this in, you can do it in Excel, you can do whatever, and then you fit it into a straight line to find the y-intercept. Okay, just put this into Excel. And I can't show you that, but I'll give you a rough drawing what it should be. And then part B, it wants to find the probability. So I'll show you how to do that to find the temperature. So we need to find the energy. And from the energy, which was what we're given, we'll find the temperature, okay? And so let us begin. And so EF is our Fermi energy. Okay. And then we have this is our energy state. And we have the K is the Boltzmann constant, and the T is the absolute temperature. So let's just draw a little table, and we'll put A here. And let's see, we have this guy here. Boop. And let's see, we have E, energy, and EV. And now we have this guy here, minus 1. And now what we're going to do is just put in ln 2 here, 1 over f e minus 1. Okay. And what you're doing is, again, we're just using this equation here. Okay. And you're just going to figure out what is that, which is this guy here. And you figured out, obviously, with the e's. And a lot of it is given constant because they give us in the problem, they already give us these two. So we already have that information. So let me just write that out. And I'll write it in red so you remember that we already have this information. And so we have 3, 0.173, 0.390, 0.661, 0.856, 0.950. Okay. And then now we have 2.5, 2, 1.5, 1, and 0.5. Okay. So obviously we have this guy right here already done. So we just do 1 over minus this. So in other words, I'll show you once, and that way you guys can do the rest. So from here, we'll do 1, 0.064 minus 1. Okay. And that is going to be 14.625. And then now we're going to the next one, 4.7803. 1.5641. And you can also actually do this in Excel. You just make a little thing if you don't feel like calculating the whole thing. Excel is a great program to learn, and so is coding, but I would recommend for this type of thing, Excel is the best one, unless you're really good at programming. 2.6827. So basically what we're doing is just putting this guy into the logarithm. And you can do that on your calculator, or again, you can do that on your Excel if you're already building it. And this problem is just one of those great examples of having Excel. And if you have Excel, you can do this whole thing on there. But if you have a professor that won't accept it, then you might have to actually handwrite out your table, which sucks. But you might be able to print off your table as well. Okay, so this is what we have for A. We're not quite done because I'm going to show you what to do. So now we are plotting a graph. And what we're plotting, it is we're using this, okay, versus this. So now what we have is we are going to have and that is not a straight line, but when you do this on Excel, you'll be able to have it straight line. Okay, so the Y is your EB, and your X is actually going to be your LN, one of here, minus 1. Okay, that way you guys know how to name your thing. We're going to have this at 0, and let's see if we can do this. So yours is going to be a lot better than mine, but we're going to have 0, 2, 3 because, again, it's not that long. We have -2, -3, and we can do -4. And you can do it if you like yours better and you want your style to be a little bit different, that's fine. I'm just doing this so that way if you're not sure what it's supposed to look like, that way you just know what it looks like. I'm going to do 2.5, 2, 1.5, 1, and 0.5. And I always hate hand drawing things. Okay, so we're going to have this one, and I'm actually going to delete this 1.5. And so you know what it is? I'm just deleting it so it's going to be easier for me to write this out. Okay, so we have 1.5, which is going to be right on this line here. And then we have 1 right here. And now we have here at about 2.5 and we 10, that's a perfect line perfectly on 2.5. And then we have 1 that is right on that 3 perfectly. And we can pretend that's on the 3. Okay. So we can pretend that's on the 3 if we just maybe lift it up. And again, now I'm just going to do one that's on the 1, and that one is right here, and 1 and 0.5, that's about here. And now what we're going to do is have that here, kind of perfect. So from here, the slope best fit is, if you do that on your Excel, is going to be 0.445 EV for your slope best fit. Okay. And now we have your y-intercept. And that is going to be on 1.8 EV. Okay. And now we can do part B. And so part B was asking you, use the results in part A to calculate the temperature and the Fermi energy of the material. Okay, so we have to use the Fermi-Dirac distribution probability. And from there, what we'll do is just equal solve there for the energy here. So when we do that, we have here E minus EF and divided by KT plus 1. Okay. And now we're just going to switcheroo everything. So we have E minus EF divided by KT equals 1 over F E minus 1. Great. And now we're just going to do E here. And we get E minus EF divided by KT ln of 1 over Fe minus 1, which is actually kind of similar to what we did earlier, if you didn't notice. Okay, we're going to times this over here. And we're also going to be adding this over. So when we do that, we'll have E equals ln 1 over F E minus 1 times KT plus your EF. And let's get that all up in there and make that a little decent looking. Times KT. This is an E, capital E. Okay. So from this, the conclusion is that the slope of the above graph is equal to KT and the y-intercept is equal to the EF, okay? And because if you look up here, this is your energy here. And our slope is the best fit. And this shows that this is basically your y equals, oops, if I can, if it doesn't mess me up, y equals, okay, mx plus b. And this is basically what this is same. And because of that, we can say your KT is going to be equal to 0.45, oops, 45 EV. And it's also saying that your EF is equal to 1.8 EV. And now what we can do is solve KT to get the temperature. And so what we're going to do is take this and we're going to do T equals 0.445 EV divided by your K, and your K is going to be 1.38 times 10 to negative 23 JK, and it's going to be 5159 K. Okay, and that's a 9 here, and that's your K, and your E is right here, and you solved your E right above. That's your y-intercept. Okay, guys, thank you.